Hi everyone, my name is Thomas Holden. I'm one of the technical managers here at Roadstone. I'm here today with Barry Gilroy from Mattest and Andre from HTL. We're here in the Roadstone Research and Development Lab, and we're going to discuss the design and supply of EN206 certified concrete for 3D printed concrete. We were approached by HTL to design concrete that could be mass produced and truck delivered, so we looked at the whole process. We looked at specification. We decided we'd do a 37 Newton concrete vertical wall, freeze thaw, durability, so 37 Newton was the concrete. We took that concrete design, the specification, the water cement ratio, minimum cement, and we ran it through our laboratory mixer. From that then we progressed to on-site trials with the truck. The production of EN206 concrete requires that the concrete is made with certified materials. The aggregates used would be compliant with 12620, the cement would be compliant with EN 197. So it's a certified product. We did the flow testing, they made cubes of the concrete, we verified the strength. But then on site we involved Mattest to come up with a process of verifying the concrete would comply and would meet all the requirements for the build. So you took over from there, Barry. So how did you find things then from there?
So yeah, Mattest were delighted to be asked by Roadstone and HTL to devise a testing protocol to ensure that the concrete produced and constructed on site complied with the specification. So we devised a very onerous testing protocol to ensure the compliance of the concrete, and this involved a suite of tests and testing protocols, so including we analysed compressive strength of the concrete, flexural strength, we looked at the bond strength, we looked at various characteristics including the shrinkage of the concrete and the elastic modulus. In combination with this, we also analysed the in situ strength development of the concrete by means of our maturity probes, which allowed us to do that in real time. The concrete produced and supplied by Roadstone and constructed by HTL met the specification in every occurrence, and indeed it actually exceeded it in almost all the criteria. I think this was down in no small part to the technical capabilities of the Roadstone technical team and HTL that we were able to produce and construct the 3D printed concrete in terms of the specification.
So we produced the concrete, bulk mass concrete, and delivered to site. When we arrived on site we checked the flow, and from that point you took over, Andre, and printed the concrete. So how did you find things from that point on?
Yeah, so as with any new technology, we had to gain the trust of our wider design team and various key stakeholders. So the tests that we set out were to gain parameters that we can share with our design team, and these parameters were to tell them more about our mechanical and durability performance of our material. So then specifically we had to showcase that our 3D printed material meets all of our design and specific performance requirements. So therefore we could show that it is still the same material even when they're being placed layer by layer, and then that it is suitable for our design intent. And so the main aspect we set out to prove is that the material that Roadstone provides to us and is being discharged into our pump from the ready-mix concrete truck is the same material that is being extruded at the end of our printhead to fabricate buildings. So therefore we use that because we know that ready-mix concrete that is provided or produced in a concrete facility is factory production controlled, and therefore it can be utilized as a code compliant building material.